This video is a review of adding fractions, and I'm assuming that you're familiar with fractions already, so let's just review what are fractions. A fraction is a number. It's a type of number. And as a number, it's a number on the number line. Let's see, here's our number line. Here's 0, here's 1, here's 2, here's -1, -2. It goes on forever. And let's just do a quick review. So what's 1/2? What are the halves? The halves are the numbers you get by taking each segment of length 1 and dividing it into two pieces. Dividing each segment into two pieces. And then the length of each of the new segments I have. So this length is... This length has length 1/2. And so this number on the number line is 1/2. And from here to here, I have two of these segments, so that's 2 halves. And this point will be 3 halves, and that's 4 halves. It's 5 halves, and it goes on forever. This is 0 halves. And when I go back, it's -1/2, -2 halves, -3 halves, -4 halves, etc. So those are the halves, and I'll write that down, halves. And you can also take the number line and split it into thirds. I can just take each line segment, each segment of length 1, and split it into 3 pieces of equal length. And this length is called 1/3. So here's 1/3 on the number line, here's 2/3, 3/3, 4/3, 5/3, 6/3, etc. And here's 0/3. And again, when you go backwards, it's negative. So it's -1/3, -2/3, -3/3. That's -4. Oops, -4/3, -5/3, -6/3, etc. So these are the thirds. And you can take the fourths and the fifths and the sixths, etc. So all the numbers obtained by this process, so continue going fourths, fifths, oops, fifths, sixths, etc. Right? You take the segment from 0 to 1, you split it up into, say, n, for n, some integer n pieces of equal length, and then you do the same thing for all the different segments of length 1, and then those numbers that you get are called the fractions. Right? Those are the fractions. So fractions are numbers on the number line. Now when you take this process of getting the fractions, you don't get all real numbers. There are some real numbers that you can't get by doing this process. But you get a lot of numbers as fractions. And one of the key, so that's what fractions are. Okay, so don't think of fractions as, a piece of a pizza or anything like that. Just think of them as numbers on the number line. Because one of the places where students get confused with fractions is they're thinking of fractions as, a part of a whole or something like that. It's a lot better to think of fractions as numbers. Okay, so let's talk about adding fractions. Well, before we talk about that, there's a very important fact about fractions, which is that any fraction can be written in multiple different ways. If you have something like 1/2, okay, so I split 0 to 1 into two pieces, each is length 1/2. I can split this interval from 0 to 1/2. I can take this interval and split it itself into halves. So I can take this line interval from 0 to 1/2 and split it into halves, and then I can take the interval from 1/2 to 2/2 and split it into halves, and now I'll have 4 equal pieces. I'll have these 4 segments of equal length, and so I'll have fourths. So this is 0, 1/4, 2/4, 3/4, and 4/4. And now you notice that 1/2 is on the same position on the number line as 2/4. So therefore 1/2 equals 2/4. And actually, I can do the same thing if I have 0 to 1 and I have 1/2. I can split the segment up from 0 to 1/2 into n segments of equal length. N segments of equal length. And I can split the part from 1/2 to 1 into n segments of equal length. Well, total from 0 to 1, I'll have 2 n segments. And each segment has length 1 over 2n. But I have, so from 0 to 1/2, I have n segments of length. So from 0 to 1/2, you have n segments of length 1 over 2n. So 1/2 is equal to n over 2n. Because n over 2n is just n segments of length 1 over 2n. Okay. And in general, the key fact is a over b is the same as a times n over b times n for any positive integer n. Okay? This is hopefully something that you're aware of. And so when you're thinking of fractions, it's really important not to think of, for 1/2, it's important not to think of 1 and 2 as two different numbers. It's important to think of this quantity, 1/2, as a single number. Okay, let's talk about adding fractions then. So, let's talk about adding fractions with the same denominator. Well, if I have two fractions with the same denominator, let's say 2/5 plus 1/5, the key thing is that I can think of 2/5 as 1/5. It's 2 1/5. So it's 1/5 plus 1/5. That's 2/5. And now I'm adding 1/5. Well, if I have 1/5 plus 1/5 plus 1/5, how many fifths do I have? I have 3. This is equal to 3/5. So in general, if I have a over n plus b over n, and a and b are positive numbers, then this is equal to a plus b over n. Because this first quantity is I have a 1 over n. I have a nths. And this quantity is I have b nths. And so when I put them together, I get a total of a plus b nths, which is a plus b over n. So let me draw a little picture. So to illustrate 2/5 plus 1/5, I have I broke up this segment from 0 to 1 into 5 equal pieces. So here's 0, here's 1/5, 2/5, 3/5, 4/5, and 5/5. And I take this piece of length 2/5, and I'm adding, so this length is 1/5. So when I add them together, I put this 1/5 length next to that length of 2/5, and I get a length of 3/5. So this is 1/5, right? Okay. So I get 3/5. So it's very important. It's a good idea when you're adding fractions, instead of just following the formula, to think, okay, I have 2 of 1/5 and 1 of 1/5, and then putting them next to each other like this on the number line. Where am I on the number line? That's a good way to think of adding it. Adding fractions with the same denominator, because then you'll understand why you would add the numerators together, because you're just saying how many total number of nths do you have. Okay, so that's adding fractions with the same denominator. Now let's say that you have fractions with different denominators. So let's do an example. Let's say you have 1/2 plus 1/4. Well, we can't do the same as what we did before, because 1/2 is what I get when I take 0 to 1 and split it into 2 pieces of equal length. So this length is 1/2. But if I have 1/4, that's what I get when I take 0 to 1 and split it into 4 pieces of equal length. Like this. And when I put them side by side, since these two lengths don't have the same, see here I have 1/4, so this is 1/2, and this is 1/4. But when you put them together, you don't know what you get yet, because before I was taking 1/5 and 1/5 and 1/5. I was taking the same unit, if you will. I was taking the same type of number and just adding them. I had fifths that I was adding, but here I have 1/2 and I have a fourth, and a half is not the same as a fourth. However, one of the things we learned is that you can represent 1/2 as a certain number of fourths, because 1/2 is the same as 2/4. 1/2 is the same as 2/4. So really, 1/2 plus 1/4 is equal to 2/4 plus 1/4. And 2/4 plus 1/4 makes 3/4. So 1/2 plus 1/4 equals 3/4. So now we see how we can add fractions with different denominators. You need to use the fact that you can represent fractions in different ways and get the two fractions to have the same denominator. And once you do that, you can add them easily. So let's do another example. Let's say that you had 1/3 plus 7/6. Well, again, I have a different denominator, but I can represent 1/3 as 2/6. And now when I add them, 2/6 plus 7/6 makes 9/6. Okay, that's not in simplest form, but mathematically it's correct. I mean, it is 9/6. Okay, so what we're doing here to illustrate 1/3 plus 7/6 is we're taking a third but you're splitting each of these thirds into two pieces of equal length. So now I have 6. And so I have 2/6. And I'm adding 7/6. So 5, 6, 7. I end up at 9/6. Okay, let's do one that's a bit harder. So if you had 2/5 plus 9/8. Well, here it's a bit harder to see what the common denominator could be, but when you look at 2/5 and look at the different possibilities, this is equal to 4/10, right? In terms of 15ths, it's 6/15, and this just keeps going. And what you notice about the denominators is that these are all multiples of 5. Right, which makes sense because you're taking 5 segments, so you're taking 0 to 1, and then you're splitting it into 5 segments, and then you split each of those into 2 segments. That'll give you 10 segments, right? That's 1/10. That'll be 10 segments to get 1, and so on. So you're going to get multiples of 5, and similarly, when you write 9/8 as equivalent fractions, you're going to get multiples of 8. Dot 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 means you just keep going. So these are multiples of 8. And so if you want a common denominator, you need a multiple, you need a number that's a multiple of both 5 and 8. And the multiple of 5 and 8 is 40. 5 times 8. So 2/5 is what over 40? 16, right? Because I'm taking 2/5. When you take 1/5, you chop the segment from 0 to 1 into 40 pieces. And 1/5 becomes 8 over 40, and so 2/5 is 16 over 40. And 9 over 8 is 1 over 40. Let's see. 35, right? 8 times 5. Yes. 9 times 5. No. 9 times 5 is 45. Okay, sorry. 45. And now what do I get? 61, right? 61 over 40 is my answer. And so hopefully this explains why we need a common denominator and how to get a common denominator. Now for more complicated fractions, so if you had something like, see in this example you could do 5 times 8. And in general you can do that, but if you had something like, 4 over 13 plus 27 over, 27 over 39, maybe not 27, 17 over 39, you wouldn't want to multiply 13 and 39 because it's too big. And so you just need a number that's a multiple of 13 and 39. In this case, you could do 39. Because it's 12 over 39 plus 17 over 39 makes 29 over 39. You just need one number that's a multiple of both denominators. So in this example, we could use the least common denominator, but for the purpose of just explaining how to add fractions and what adding fractions really is, you're just taking, right, two pieces and putting them next to each other and seeing how long that is. This is adding positive number fractions. It doesn't matter which denominator you use. It doesn't have to be the smallest denominator. All that matters is that you get a common denominator. Okay, it doesn't have to be the least common denominator or anything like that. Okay, so I hope that this was a good review of how to add fractions and why we add them the way we do. And a lot of people explain fractions using parts of a whole, but that really is, I think, not a good way to explain how to add fractions. Okay, thanks.